Hey everyone, welcome back. We're here for a few more questions on the Unit 5 unit review. So, first of all, shout out to Ben for requesting this question. Thanks, Ben. We're on number 5. The question is asking us to identify the terms and tell what that means. Now, remember, terms has a lot of different meanings in different contexts. We talk about a president serving 4 terms, or I'm sorry, 2 terms in office, which means 2 sets of 4 years. So those are their terms. When you're in high school or college, you might have a term paper that's due, which means it's a paper that kind of encapsulates the whole of what was going on in that particular semester or whatever your length of time is. Those are not the terms that we use when we're talking about terms in math. So, see what I did there? Okay, so in math, terms are either numbers or letters or groups of numbers and letters that are added or subtracted. And that's super, super important. We're looking for things that are added or subtracted. So we are going to start with our order of operations and try to kind of look all at the whole problem till and kind of pair it together until we find things that are being added or subtracted. So we're going to use the order of operations to approach this. So the first thing is parentheses. Do we have any parentheses that we need to think about? Not on this problem, but we always want to start with that. Even if we don't see any, we think to ourselves, okay, are there? Because that's the first thing. The next thing is exponents. Yep, there are. So we're going to circle that. A squared. Okay, what about multiplication and division from left to right? Remember, we read left to right, we solve multiplication problems from left to right, and division, and it doesn't matter which one it is, multiplication or division, we go from left to right. Well, 10a. Remember, if a number and a letter are stuck right next to each other, there's an invisible multiplication sign in there. So that's being multiplied. So there's a multiplication problem, 10 times a mystery number, which we're calling A. Anything else? No, we still have something, don't we? 9 divided by 2. So we skip over all of this other stuff because we're looking for all multiplication and division problems from left to right. So 9 divided by 2. Now we're to adding and subtracting. Take a look. This, these two are being added, these two are being subtracted. So we found the terms. Here's one of the terms, there's a second term, and there's a third term. And how do we know? It's because everything in between all of those other things, we're looking at, there's an addition sign and there's a subtraction sign. So we've got numbers, letters, or a combination of numbers and letters that are multiplied or divided, or in this case, using exponents, which is also multiplying. So those are the terms. Thanks for the question, Ben. Okay, our next problem is number 16. So shout out to Garrett. Thanks, Garrett, for requesting number 16. So number 16 is an inequality. That means that whatever's on this side may or may not be unequal to whatever is on that side. So it's a teeter-totter problem, but we have to remember that this sign means that this side is going to be bigger than or equal to this side. Now that's tricky. We have to remember that we're thinking about that it might be bigger. This is the greater than sign, so it might be greater than, or that bottom sign says it might be equal to. So it might be greater than or equal to each other. So let's dig in. This is a mystery. It's a variable question. So get your materials out so that we can model it out. So I've got my Pringles out today. So let's start by modeling 6 groups of a mystery amount. Remember, if a number and a letter are squished right next to each other, there's an invisible time sign. So 6 groups of a mystery amount. So I've got 1, 2, 3, 4, 5, 6. Can you see that? Well, it's kind of hard to see. Let's do it this way. There we go. Can you see that? Yep. Okay. So there it is. There's 6 groups of a mystery amount. Now, here's our greater than, less than, and equal to sign. It's facing this way, so we read it as the greater than. So 6 groups of a mystery amount is greater than, or it could be equal to 13. So what that means is just 13 random Pringles. So I'm going to just get out 13 random Pringles here. Okay, so we've got our 6 groups of a mystery amount. We've got our 13 individual Pringles there. We've got our greater than or equal sign. Is there anything we're missing? We haven't taken away 5 yet, have we? It's 6 groups of a mystery amount minus 5. So what that means is we go into one of our mystery groups, we open it up, and we take out 5. Oh, there's some broken ones in here, so we gotta see if I can take out 5 normal ones. 1, 2, 3, 4. 5. All right. So now we're taking away these 5. So we have this group of a mystery amount, 6 groups of a mystery amount. We're taking away 5, and that is greater than or equal to 13. Now, the trouble is when you take something away from a group that you don't know what it is, it gets tricky because you don't know what that could be. If you don't know what you started with and you take something away from it, it's hard to know. So let's use the inverse operations. We want to try to isolate the variable. That means get the x, get the one group of a mystery amount all by itself on one side. So let's use an inverse operation strategy here. Instead of reaching in and taking these 5 out, let's add them back in, but we can't do it to just one side. Remember, on the teeter-totter, if you do something to one side, you got to do it to the other, or it won't work. You can't teeter-totter. So if we add those 5 back in there, let's add 5 more on the other side too. So let's take these and stick them back in here. And then let's take 5 more and add them to this side. 1, 2, 3, 4, 5. Now, here's what we've got. Here's what our problem is. We have 6 groups of a mystery amount. It's all groups. We don't have to do anything with it. It's just 6 groups of a mystery amount. And it's greater than or equal to. We had 13 over there before. We added 5. So we have 6 groups of a mystery amount is greater than or equal to 18. Now, here's the isolating the variable part. We don't want 6 mystery groups over here because we're not sure what could be in those. But we could know what it was if there was only 1. So instead of 6 groups over here, we're going to again use the inverse operation. Instead of multiplying by 6 groups, we're going to divide by 6. What's 6x divided by 6? Just one mystery group, isn't it? So we're going to divide by 6 and get rid of all of these other things. We don't want those. We're going to divide it into 6 different groups and get rid of those. But we can't just do it on one side. We have to do it on this side too. We divided this side by 6. We took 1/6 of it. We also want to take 1/6 of that. What's 1/6 of 18? Or what's 18 divided by 6? Well, you probably know a fact that solves that, don't you? So over here, all we're left with is one mystery group. Over here, 18 divided by 6 is 3. So we're going to take these and divide them into 6 groups. 1, 2, 3, 4, 5, 6. Now we're going to do it again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we only want one of them. And look at that. It's 3. So what's in the mystery group is greater than or equal to 3. Now, because this is an inequality, and they're kind of new for us still, let's go back and make sure that the inequality part works. We know the equals part works because 6 times 3 is 18. 18 minus 5 is 13. 13 equals 13. So we know the equals part works. But let's just go back and double check. What about the greater than? X is greater than or equal to 3. Well, let's try 4. What if we said x equals 4? 6 times 4 is 24. Minus 5 is greater than or equal to 13. Is that true? 24 minus 5 is 19. Is 19 greater than or equal to 13? It's greater than, isn't it? Yeah, so that one works. What if we tried x equals 5? Because remember, x equals something that's greater than or equal to 3. So let's try 5. 6 times 5 is 30. We keep the minus 5. 30 minus 5 is 25. Is 25 greater than or equal to 13? It is. That's how inequalities work. We found the number that's the equal part, and by that we can then assume that anything that's bigger than 3, even 3 and 1/10, 3 and 1/100th, we could try, and they'll all will work because as long as they're bigger than 3, or in this case equal, it still works. It still solves the problem. Let's go on to the next one. All right, our next problem is number 17. Number 17 is 10 plus x, a mystery number, equals 3x. Remember, when a number and a letter are squished right next to each other, it means multiplication. 3 times x, 3 times a mystery group. So let's get started and model this out. First of all, we need 10. What does 10 mean? It means just a group of 10 measly things. So I need to count out 10 Pringles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you're working along with me, please pause. At any time, pause, go get materials, come back and work with me. Don't just watch me play with math. You should be playing with math. Okay, so there's our 10 measly Pringles. Plus, we have plus x, plus a mystery group. So there they are. There's our 10 mystery Pringles. There are 10 Pringles plus a mystery group, and we know that equals 3 mystery groups. So there we go. So this amount equals this amount. Now, how are we going to solve that then? What are we going to do to try to isolate the variable, to try to get only one mystery group on one side? Pause and see if you can do it. All right, I've drawn a teeter-totter for us. So on one side of the teeter-totter, 10 and x are teeter-tottering. On the other side, 3x, remember, is just like x plus x plus x. So we've just got x plus x plus x. Now, we want the x's all to be on one side. We don't want to have x's on both sides because it's hard for us to figure out the answer. This is 10 plus x. What if we just said, ask the x to get off on this side, get off over here, but we can't just ask one thing to get off on one side because it won't be balanced. You can't teeter-totter. What else do we need to do? We need to ask one of those x's to get off too. So we're using the inverse operation. Instead of adding this x in, 10 plus x, we're going to subtract that x. We're going to take that away, but we can't do it to just one side. So we're going to subtract an x over here. What we're left with is 10 on one side and 2 x's on the other side. A group of 10 individual Pringles equals 2 groups of a mystery amount. Now you're probably saying, I know a fact that solves that. If this plus this equals 10, I know that has to be 5. And you're exactly right. It is 5. 2 groups of 5 will give us 10. Let's see how that works using the inverse operation. We've got 10 equals 2 groups of x. Again, we have 2 groups of a mystery amount. We don't want 2 groups, we want 1 group. So we're going to, instead of multiply by 2, we're going to divide by 2 so that we only have 1 there. If we divide this by 2, we have to divide this into 2 groups and take one of them. So we have to do 1, 1, 1, 1, 1, 1, 1, 1, 1. We divided that into 2 groups. We're taking one of them and getting rid of the other one. So now we have x. We isolated the variable to put just one variable, one letter on one side, x equals 5. 5 equals x. Great job. See you next time. Thanks for requesting the video, Garrett.